Beneath the frozen tundra of the Kola Peninsula, hidden from the eyes of most, a silent needle of steel pierces the planet's crust. It is a venture born of ambition, curiosity, and Cold War rivalry, a project that would plunge humanity farther beneath the surface than any previous endeavor. This is the tale of the Kola Superdeep Borehole, the deepest artificial aperture ever created, and the secrets it unearthed about the very bones of Earth. The story begins in the late 1960s, when the Soviet Academy of Sciences announced a bold scientific challenge, to drill a hole a kilometer deep, then 2, then beyond, to finally breach the mysterious boundary between the crust and the mantle. The goal was not merely technical, it was a quest to test theories of plate tectonics, to sample rocks that had never before seen daylight, and to demonstrate Soviet prowess on the world stage. Choosing a site was a meticulous process. Geologists scoured the Kola region for a location with stable, ancient crust, low seismic activity, and minimal groundwater intrusion. The chosen spot, near the village of Nikitskoye, lay atop the Baltic Shield, a Precambrian mass of rock older than most mountain ranges, providing an ideal laboratory for deep earth experiments. Construction of the drilling complex began in 1970. Massive concrete foundations anchored a towering derrick, while a network of pipes, pumps, and cooling systems was installed to manage the extreme temperatures and pressures that would be encountered. Engineers faced a paradox: the deeper they drilled, the hotter and more abrasive the rock, demanding ever more resilient drill bits and sophisticated lubrication. The first meters fell away with relative ease, revealing layers of sedimentary rock and ancient marine fossils, a reminder that this frozen land was once a seafloor. Yet as the borehole descended past 1,000 meters, the temperature rose to 40 degrees Celsius, and the rock became denser, demanding a switch to diamond-tipped bits that could grind through granite with painstaking patience. By 1974 the borehole had reached 7,000 meters, a depth that no human hand had ever touched. At this point, the drilling crew encountered an unexpected phenomenon. The rock temperature surged to 180 degrees Celsius, far hotter than predictions based on surface measurements. This discrepancy sparked a scientific debate about the thermal gradient of the crust and forced a redesign of cooling fluids to prevent the drill string from seizing. The deeper the shaft, the more the earth seemed to resist. At 9,000 meters, the drill encountered a layer of metamorphic rock riddled with microscopic cracks, causing the drill string to wobble and the borehole walls to collapse. Engineers responded with a novel approach. They injected a cement slurry to stabilize the walls, a technique that would later become standard in deep well drilling worldwide. In 1989 the Superdeep Borehole reached its record depth of 12,262 meters, a staggering 40,000 feet beneath the surface. To put that into perspective, the hole was deeper than the cruising altitude of a commercial airliner, yet it never breached the mantle. The deepest point lay within the upper crust, where pressures exceed 350 MPa and the rock behaves more like a viscous fluid than solid stone. The scientific harvest from that abyss was extraordinary. Core samples revealed ancient granites dating back 2.7 billion years, containing microscopic pockets of water trapped since the planet's early days. Unexpectedly, geologists discovered microscopic fossils of single-celled organisms at depths previously thought sterile, challenging assumptions about the limits of life beneath the surface. Perhaps the most provocative discovery was the presence of a thin layer of hydrogen-rich gas at around 7,000 meters, hinting at chemical reactions between water and iron-bearing minerals deep within the crust. This finding sparked new theories about the deep carbon cycle and the role of subcrustal processes in regulating atmospheric gases over geological time. The borehole also served as a laboratory for seismic studies. By placing sensitive geophones along the shaft, scientists recorded how seismic waves traveled through different rock layers, refining models of Earth's interior and improving earthquake prediction methods. The data gathered helped calibrate global seismograph networks still in use today. Yet the project was not without controversy. The immense financial cost, over 200 million rubles, sparked criticism from Soviet officials who questioned the practicality of a hole that never reached the mantle. Environmental concerns also emerged, as drilling fluids and waste rock threatened to contaminate the fragile tundra ecosystem. In the early 1990s, with the dissolution of the Soviet Union, funding evaporated. The drill was abandoned, its shaft capped, and the site fell silent. The borehole remains a testament to human ingenuity, a vertical scar that still whispers the stories of ancient rocks, hidden gases, and the relentless push to know what lies beneath. Today, the legacy of the Kola Superdeep Borehole endures in modern scientific pursuits. Contemporary projects like the German Continental Deep Drilling Program and Japan's Chikyu scientific drilling vessel build upon its lessons, employing advanced drilling fluids, real-time telemetry, and autonomous drilling rigs to chase the mantle's edge and even sample subsea crustal plates. The deepest hole ever dug reminds us that Earth is not a static sphere but a dynamic, layered world. Each meter we descend peels back a chapter of planetary history, revealing that the line between the beneath the Kola Superdeep Borehole, scientists discovered microscopic lifeforms thriving on chemical energy alone, a reminder that even in absolute darkness, biology can carve out a niche, redefining the limits of habitability. The immense pressure at 12 kilometers transforms rock into a plastic, slow-flowing mass, a phenomenon that engineers study to improve drilling technology for future geothermal energy extraction. Seismic reflections captured from the deepest holes reveal hidden fault lines, offering clues to the mechanics of earthquakes and providing a potential early warning framework for at-risk regions. The temperature gradient, rising nearly 30 degrees Celsius per kilometer, forces engineers to develop ultra-resistant alloys and cooling fluids, innovations that later find applications in aerospace and deep-sea submersibles. Data from the deepest boreholes feed into global climate models, as the heat flow measured deep underground helps calibrate predictions of long-term planetary warming trends. Cultural legends have long spoken of a world beneath the world. The modern pursuit of the abyss bridges myth and science, inspiring a new generation of storytellers and explorers alike. International cooperation is essential, funding, expertise, and technology flow across borders, turning the deepest hole into a shared monument to humanity's collective curiosity. As we contemplate the final meters, the question shifts from, how deep can we go, to, what will we find there? Potential new mineral phases, unknown fluids, perhaps even clues to Earth's early formation. The story of the deepest hole is still being written. Each new dataset is a line in a manuscript that may one day guide us to the very heart of our planet, and perhaps, to the thresholds of other worlds.